So our topic for today is references. References, and let me open IntelliJ. Maybe we will start just from the very beginning and from the just examples. Okay, so I will create just simple class. So let me call it class simple class, and I will have public field here I, integer field, and for example I want to have integer also variables I equals 5. I need to disable Codium. I don't want any advice here. And int j equals 3, for example. And guys, when I make this stuff, j, or let me make it I equals j. So what the result of this code? Tell me, please. Okay, yeah, there are some process, but what the result of that process? So
we assign 5 to assign I to j, so it goes, it allocates memory to j.
Okay.
And then it's gonna be.
So what are the options? Yeah, so I will be equal to 3. Okay. Okay, so we have this I initialized in main, and here we have assignment, and we put new value into I. This value is 3, right? What value of j? Still 3. If I do this, what value of j after that? What value of I? Still 3. So let me put it here. And let's check if you're correct with your answers. Yes, you are perfectly correct. So I equals 3 and j equals 10. Let's make the same experiment but with object. So I declare variable of simple object, simple class. Simple class. And let it be A equals new simple class. No constructor there, so we will assign value of I manually. Let it be 5. And the same with B equals new creation of new object, simple class, and B I equals Howie 3. Now, what I want to do? I want to do kind of the same stuff. So I equals J, it will be A equals B. Let it be like that. Bless you. We should keep safe, guys. What the result of this line? when I output I, what will I have here? I will have 5, you think.
I think we will have 3 maybe.
I will have 3. So what exactly we will have here? 5 or 3? You think 3. Okay, let experiment. So I will comment this code, so it will not bother us with output. We basically have 3. Now, let me make this b I equals, how we did it here, 10. Okay? So what the result of this operation? What will be changed? B dot I will be 10, right? Let's check it. Exactly. But my question is, what will be in this output now? 3, 10, 5? What exactly? Who for 3? Raise your hand. Who for 10? Raise your hand. What happened here, guys? So let's be very precise here. So I will put exclamation marks. Now, we should dig deeper into that. We have 10. How could it be? We have 10. Okay, good philosophical explanation, Yaroslav.
We've got the pointer b, so if we change b value, we will have this value into a.
Okay, good explanation. Ilya, what do you think?
We just say that a is a, we don't just reassign a value for a, we say that it's like equals to an object, so it will remain throughout all our program.
Yes, so let's start thinking about that. So when we create object, or when we create local variables like integer I, like previous example, which is commented now. Okay, how deep should I go? So yeah, let's be more precise. So we have this area for local variables. This area basically is placed in stack. Okay, so we now put in the stack main method. So this is our main method. For this main method, we have also method area, another part of the memory with exact instructions of this method, and with the instructions of other methods of our program. This is basically our class bytecode being put in memory in some method area it's called. So, but when we call method, we create stack fragment or like stack frame for this method frame, let's say, or stack frame for main method. And in this stack frame, we have these arguments. For example, these arguments will be also here, like any arguments of our methods, if any. And also local variables. So for example, I, j, we create these variables. And when we assign value to that variables, we assign 5, we assign 3. So we execute line by line. and okay, now it's 5. Then we assign j to I. So what happened there when we assign j to I? We basically take this value, put that into I. So now it is 3 here and 3 here. So we have 2 places in memory, and that places just contain basically value, and that's it. But what happened? Then we come to the program counter, or the line of, let's say, of our code or instruction, when we create object. We create object, and now we have something different. We have also this part of the memory, which we call heap, kucha. We have this dynamic memory, let's say, and many variables in Java world, in any other language world, we have like this kind of local variables, non-reference variables. And we have reference variables. And reference variables use this dynamic memory. So we create, how we call it, a class here. What happened here? So yes, we created this variable a, but what is value of this variable? The value of this variable, if to be precise, not basically exact object as a value, but rather reference to the object. So we execute this new simple class, and at this moment we create, in the heap, we create object of simple class with some address. This is the address of this object in the memory. Okay, let's create any number, just virtually, I don't know. So, and we put this basically address here, but not the object itself. You should understand that. So our a now, after this line, will refer to specific part of the memory. Then we go to the next line and we access inner stuff of our object. So inner stuff of our object, we have I, and we put value of 5 inside this object, some inner stuff of the object, but it been executed, been performed in memory, in dynamic memory. Then we create new object called b. So yes, we have this variable here, but what will we put here? What will we put here?
The address of B.
Address of b. So first of all, we create new object in memory with some new address. Let it be something like this. So we put address here, and b is reference to this new object in memory, in dynamic memory. Then we execute next line, and we access b and put I to 3. So we had I at the very beginning with okay, default value for objects for private for any attributes will be like in integer will be 0. So we had 0 before, then we put 3. So that's why we access this memory. We put 3 here. But the main idea that b is referring here and a is referring there. What next? Next, the most interesting stuff. A equals b. We assign b value to a. What that mean? What is b value? So not the value of the object, let's say, but address. So we put here this address. And now what do we have? This link being destroyed. We have no any link to this object now, and something interesting will happen there. But we have two kind of references to the same object. Do you remember? Okay, tell me in your experience of using operating system, what it remind you, what this principle remind you? Shortcut, exactly, or alias in Mac OS. So we just create alias or shortcut to the file. We could manipulate with these shortcuts, but file is existing just separately from that shortcut. This is exactly what we have here. So we have two variables. Yeah, basically two objects, but under the hood it's just one object. They just point the same object in memory. I will back here, just remind me to explain what happened here, but let me move to this line. Now you understand. When I access b.i, and put here 10, and then what? Then I access a.i. A.i, now you see why I have 10 value. Yes? Does it make sense now? Yes. But what happened with this stuff? We have wonderful mechanism in Java which called garbage collector. Now, this stuff without any links to it become what? Junk, just garbage. We should throw it out. And this is big blessing for us. So, because we don't need to make it by ourselves. Because without garbage, so what garbage collector actually does? Just destroy it and free the memory. Wow, good news. We have free space in memory now. But for languages without garbage collector, for example, C++, you should do it by yourself. And if you do it badly, you will have memory leaks in your programs. And that's headache. But of course, you pay for garbage collector. This is additional performance. This is additional algorithms being executed by Java and so on. But actually, of course, from kind of user experience of programmer, of course, this is a huge blessing to have garbage collector. So the idea of garbage collector is that at that moment, when we have no any links, any references to that object will be destroyed from memory. And this principle been used in many other languages too. So you should understand that. This is the main idea. And please tell me if you have any questions.
Yeah, but like we still have reference to these objects that we destroyed, like in senses, like 8 points, like that, and we still need to hold them.
Which
Like we still have reference.
yeah, which line?
17.
17. Okay, at line 20, we just lost reference to initial A object. So we just make this arrow point here and not here anymore. That's why we basically have no references to this object anymore. Yeah, so this line actually line 20 does a lot. So yeah, 17 is in the past. We already moved through that. So there is no 17 lines. This is in the past. Now everything is new. And garbage collector, hello, just put it into garbage. So we have no. But that's interesting question. For example, guys, of course, this is not, my goodness. Okay, so this is not all the information we need to know. Let's experiment more. Let me create a method here. Well, let it be static methods at that moment. Static do something with object, with simple object. And we will have simple class. Let's call it object. And we will do something. Yes. Okay, now it looks better. And let's assume that we want to perform some action with this simple object. For example, I want to access my only field and put 100. No, let it be 500. For example, I want to do this, and I want to output this value. So I access my object I. You understand this method? We just passed object here, we do something, we output it. And I want to call this method. Do something with the object. Let's decide which A or B we will put there. Okay, let's use A. And so at this line, what console output will I have? Let's run it. And of course, we have this 500. The question is, what will I have at this case? 500 or 10? What exactly? Who for 10? Raise your hand. Who for 500? Raise your hand. Okay, so I don't know who will win. Let me run it, and again, what do we need? Question mark. And let's go. Guys, unfortunately, for those who make wrong choice, we have 500. Why? Yes. Link to the same object.
Yeah, so we changed the, so to say, in the reference, we change for everything. So we can call B, it will be equals 500.
Yeah, so this is the question. Sophia, anything to add? Exactly your answer, yeah? Right. So let's meditate on that. We have this one more method here. We have these instructions. And we come to this line number 26. So we point, our program counter points to this line. And what? We create new stack frame. Of course, that would be better to put this previous stuff here, and we create new method frame here. And of course, we should remember that program counter of our previous method, so our pointer to previous method, let's say, where to come back after calling this method. And we pass parameters. This is part of our stack information here, stack frame. And we have this object parameter. So object been passed here. And when we call this, so let me remind that we have A and B, and A and B have value of this kind of address, like the same. So when we call this method, what value of argument of object? What value of that? You're already sleeping maybe, so this is address. This is not value of the object, so this is the same address. The same address, the same address, the same address. Many references, but basically one object in the memory. So when we perform this action, we have our own program counter, and we execute line by line, and we have this line object.I equal 500. So we access basically our genuine object, and we put 500 here. We do not return anything, but we get this side effect. We just call this, then we finish with this method, and we come back to our main method. So we finish with that, our stack being freed. We come back to our counter of our previous method, but something happened. That change persists, right? Because we change just the same object. And this is it, so you should understand that. So if I do this trick with array, I will get the same, because array what? Array is a reference type. Array is a reference type. Strings kind of also objects, but they could not be changed, and Java creates just new string every time when you assign new literal values. But basically, strings are also objects, also reference types. But what is more important now for me to explain to you that you should know that object of classes, they are reference types, and arrays also reference types. So if you perform, like some one of you, if you perform any actions in your methods with your arrays, you access the same part of memory. And you will change your array, that initial which come into arguments, because you pass not value, you pass the reference. That's why you should know, and please check it in your notes, that there is two ways of passing arguments into methods: passing by value and passing by reference. So every time you pass integer, double, in all this stuff, you pass by value. Every time you pass arguments into method of objects or array, you pass by reference. So again, if I create method which get integer value, and I run this method here and put any existing variable, I could change this variable inside the method, and this variable will not influence initial variable in that method in that context from what I call the method. Do you get that? Because it is passed by value, just value, no reference here. So this variable actually is clone. This is not the same, this is just copy. But when you pass arrays or objects, you pass by reference. So this is pretty much good and intuitive stuff. Of course, in other languages, including C++, you manage this by yourself. You decide. You could even pass by reference. You could even pass integer variable by pointer. So it is also possible here. But in Java, we have this more straightforward restrictions and approaches. So objects, arrays, every time you pass not by value, but by reference. So every action you do with arrays or objects inside the method will influence that initial object. Okay? Do you understand that?
Yeah.
This is quite important. Yeah.
The first question, are strings specified variable?
Okay, good question. So when you pass the string, then the copy of string will be created. Basically, if you pass string here and change it, it will not influence initial string which you pass from here. So a string is immutable object. So if you even access new value to the string, new object of string being created and assign it to the address of that string. So tricky stuff is executed with strings. But because of strings are still objects and they still reference something in memory, so when you create string, it is basically you create something in memory, and you have one string, S1, and another string, S2. And if you assign S1 to S2, or you want not assign, but you want to check if S1 equals S2, as we do with integers, you can do that, but you do what? S1 dot equals. Do you remember that? Why? Because strings are objects, and this is not any sense to compare addresses. Why to compare two addresses in the memory? We compare contents of that strings. That's why we call this tricky stuff like method is equal and so on.
So with objects we can also use equals, yeah?
Huh?
With objects we can use also equals, or we can...
A good question. So how to compare two objects? Exactly. So depends on your task which you have. If you want to compare exactly addresses, maybe you want to compare, like in our code, if A referred to the same object as B, maybe you have this task. We almost never have this task, of course, but maybe, and you could compare that. But if you want to compare AI equals BI, maybe two fields, you of course could use that. But if you want to compare all the contents of one object with another object, again, we do not often do that. I should express that. But yes, you could use if I'm not mistaken, this is part of this very root of our hierarchy of objects in Java. We have this methods, and we compare like that. But we should redeclare this method is equal. Redeclare like in R, so it become complicated to explain. So we should redeclare this is equal method in our own object hierarchy and say, okay, when my user want to compare this to object, I will basically do this operation and that's it. So we should implement that operation. Yeah, in our own class. And then we could call this method and that will be. But if we don't, then it will compare hashes. And what is hashes? So it become more and more, I should explain more and more stuff here. So basically the idea, yes, you should just keep in mind that you can do A equals to B if you want to compare business logic, not addresses. So like contents, like actual business value of that objects, you can't do this. No. And one more thing I want to emphasize here before we finish. What happened when how it was here? Yeah, this is not very interesting. Let me do like this. A equals LGD is too smart. What happened in this line? You should also know. What happened in this line? We declare an object, but we not initialized. You know that A is not actually value, but what? Reference. Now my question, reference to what A will be at this line? Yeah, reference to nothing. And we have specific data type to express that in Java and with other languages. So when we have reference to nothing, it wasn't initialized yet. This reference will contain value of null. Yeah, just value of null. So yeah, this is just nothing. This is our way to say that this reference has no basically any reference. So you should also know that sometimes you will have this error, oh, null something and so on. So what that mean, this null? Null is a reference to nowhere. So this is empty reference. This is null. When I initialize A, okay, this is reference to something. But before I initialize that, this will be null. So it is also useful to know. Any questions?
Not really regarding this, but if we have two arrays with different size, for example, 3 and 5, and we like do like A equals B, will that work?
Are you
Yes.
arrays or
Like I try to like kind of reassign the pointer. So will that work?
So we have one array, we have another array with values, and when we make, okay, let it be B equals A, then yes, exactly, reference of A will be assigned to B, and now B and A looks to one array in memory, and this will be just destroyed.
Size
Size
doesn't matter.
doesn't matter. Yeah.
I also have a question. So if we assign A to null, null means that destroys it evaporates. So value evaporates to the null. So it surrenders to the null value. So my question is, null mean whether null means exactly like 0, and if we assign value to 0, therefore there is no value.
Yeah, good question. So the meaning we should understand, null is null. So this is just specific data type in Java. This is just specific data type with one single value. Null data type and null value of that. But the question is interesting question that I actually could have maybe array and or object and then I could do it manually. This is also possible. I could broke the link to specific object, for example, or array. I could broke the link at this moment. So I broke this connection. And maybe it will kind of call garbage collector. If no other links to this object, then this object will be destroyed. So that's why it is sometimes very useful to make this very straightforward kind of line to say, yes, now A is null. But null is null. So this is kind of specific technical data type, technical data value.
So it's used instead of just a simple number 0 as,
Yes.
as it's written around.
Yes, because 0 is integer or double. That's why we can't use 0. Yeah, this is just specific like null. When you learn discrete mathematics, we have like sets, this theory of sets, and one set could have many elements, or set could be null, could be empty area. So this is very similar idea which we have in mathematics, and we have this. Maybe you know this, Mark. Do you remember maybe somewhere you in this? So this is like null set. The contents of set is null. So is emptiness like, and null. This is just very similar to that. Yeah.
Explain null in some other way. Null is the box of the memory in the 16 числово system. So instead of writing this box, so to say, we call it null. So
Okay. Yeah. Maybe we could call it like this. Yeah. This makes sense. So addresses we use powers of 16 like a system, of course. But anyway, null still this specific data type. We should know that also. Okay. Any other questions? Fine. Thank you for your attention. So see you on Thursday. You could still work a little bit here. So thank you. See you.